Okay, cool. So thanks for having me. And today I will quickly go through what the project is. So in general, this is a connected vertical blueprint. It's a project of Akraino and Linux Foundation Edge. And this blueprint was sponsored by Tencent, ARM, Intel, and as well as Nokia. So that's a general. So let's dive into the details. You can see the tables contains here, and my presentation is consisted of the following parts. And first, a general introduce what is blueprint is, and as well as background. And the second bullet will be will let you guys understand what the use case for this blueprint and how we can use that. And after you understand the use case, I will introduce the network architecture to let you understand how does this blueprint are deployed in a network. And beyond this network architecture, I will let you understand the detailed architecture and what we did in our company about how many components in the MEC and how we deployment and the major components as well. So the last bullet will be the future plan. Let you understand what we will do in the future and how much technology we will release in the future. So that's the general information. So here let's focus on the first part, the background. So in general, this connected vertical blueprint is focused on established open source MEC platform, which is are used for the virtual application. So it was established in Akraino communication community on March 14, 2019. The first release is around several months later. So you can see that very shortly. And the vertical and the blueprint is sponsored by Tencent, ARM, Intel, as well as Nokia. I'm the PTL, so you can contact me if you have any problem with that. So that's the general information and the background. So some real meat here will be the use case. So maybe you guys will ask why we need to do this blueprint. What is the benefits to our customers? And in general, we have wrapped up information for full major use case in our company. We want to provide the following service to our customers to let them understand the value we can bring to them. The first use case will be the accurate location. So right now, you can understand the GPS system we use is good, but it's not good enough. The location was not quite much accurate. So we want to improve it a little bit. We want to improve from right now 5 to 10 meters to around minus 1 meter. So that's a major use case for us. We want to make people use a very smart navigator. So if you can figure out the accurate location and you can grab the real-time traffic information and you can let your navigator get smarter. So the next use case will be the smart navigator. So you can figure out the way based on the real traffic information. So that's the second. So the third one will be the self-driving improvement. And sometimes you can see this picture here, my mouse here. And sometimes when we're driving in our street, sometimes we can't see all the dangers in the driver's view. Sometimes here you can drive the car A is driving or after a very large shuttle bus. Maybe you want to go beyond the shuttle bus, but there's dangers there. There's a car B driving pretty fast on the opposite side, which means maybe it's pretty dangerous. So we can figure out this situation. We can send the alert, send the message to the driver of the car A so that they understand. Okay, you cannot turn right now. You cannot go beyond the car, the shuttle bus, because it's huge dangers for you. So the third use case will be we were trying to help people to drive more safe. And the last point is that we want to reduce the traffic violation. Personally, I believe is a huge help for a foreigner or people who try to drive to a place where they are not familiar with. For instance, if I was a foreigner, I would drive a car in California. I don't know what a carpool is. Maybe I will be fined a couple of $100. So if there's a service, we can send information to the car driver to let you know, stay away from the carpool when you are thinking to drive. to make sure you don't violate the traffic rule. So that's why we huge help for the driver to make sure to help them to save lots of money, right? So that's the four major use case, and we have wrapped up in our team, and we are trying to provide this service based on this blueprint, based on this MEC platform. So that's a use case. So here we dive into network architecture and how does the use case can be fulfilled in the real life. And you can see there are cars driving on the street. They send the sync and their data to Node B, and Node B will send the data to UPF. It's a network connection in 4G or 5G, especially in 5Gs, and the UPF will disaggregate from the code network, which means it's more closer to the end user. So you can see it here. So right now, in 5G, our generation, we want to do is we want to dispatch the data from the UPF. You can see that UPF can dispatch the data to the MEC edge computer data center. So what our team doing is we figure out a way how to dispatch data from UPF to the edge computer, which we call a connected vertical MEC platform. So when we receive the data from the UPF, and we can send the data distributed module, and distributed module will do a second time our data distribution to the vertical application. So you can see vertical application is right here. So a lot of the use case, different apps was ran in the vertical application component here. So you can see there are lots of some low, actually it's ICE level of hardware, there is ICE software and framework here. So you can see there's physical server, it can be our ARM server, it can be Intel server, and the ICE layer we can use the OpenStack or Starling X or whatever, lots of ICE component to make to set up our virtual machine and containers and for the high level application. And if we have our physical device, virtual machine and container environment, we can set up TARs with a microservice framework on top of that. And we can use TARs to deploy the vertical application on top of that. So that's the general architecture for this MEC platform. And beyond of that, and we have the management and orchestration interface where the people are to configure some configuration based on their requirement. So something needs to be highlighted. The key component will be the distributed module, like what I said previously. And once we receive the data, we need to understand which data should be sent to which application. So here we need a policy, and we can configure about ourselves, or we can provide an API interface so that the different people can configure different applications to configure their policy by themselves. So that's the network architecture for this. Sorry. So that's the network architecture for connected vertical blueprint. So next page, we're diving into a little deeper. We're trying to let you understand the details of MEC edge cluster. So you can see from physical level, we need to use some physical drive, a physical server, and each server. You can see each box is a physical server. So here, for instance, we have full physical server here. We need to deploy some software on top of the hardware to make it work. So you can see we use one server for each operating system, and we add some software like DBDK send data back and forth. And we receive the data here, and like what I said, we have a data distribution module. This module can be configured, the policy can be configured. Once the policy was configured successfully, and we forward data to the server where the real application ran. So you can see the rest of the three physical server, we ran lots of, we ran vertical application on top of that. So you can see the vertical application ran here, right? And the task here, we use task master to connect to the different physical server. Actually, the task master was talk to task agent in different physical server. So the task must have ability to monitor the status of the different vertical application. We can figure out whether it works well and whether we need to scale out or we're scaled down, and a lot of things like that. So that's more detail for the MEC edge cluster. So next page is just a very high-level architecture that you understand. We have hardware in field, and we have our ICE are here, and from Pathway we use TARS as microservice request, and we can use some components from OpenNS. OpenNS can forward some data from their components to TARS. So there's a TARS and OpenNS that can work with each other. So that's a high-level architecture. So here, I want to dive into a little bit about TARS. So as a previous, as I talked in the previous separate page, you can understand TARS is a major component for our platform. So you can see TARS can be easily deployed flexible in the physical machine or virtual machine or container environments. And on top of that, the TARS provided the service management function and RPC, or core function as well. So you can see if go back to this page, if the application want to talk to some application in other server, and our TARS provider the RPC, our function call for them, let some master can talk to the agent, and let different TARS agents talk to each other as well. Beyond that, it can let vertical application running server A can talk to the vertical application running server B and server C. So in general, it provides a similar RPC call like gRPC did. But beyond that, TARS provide support their private protocol as well. So like we support Google the protocol buffer. Beyond that, we support TARS or private protocol, which is a very hard performance RPC protocol as well. And if you don't like TARS, if you don't like Google protocol buffer, you can use SSL, HTTP, or third party. So there's very flexible protocol we support in the TARS. And in the data center back and forth mode, we support synchronized, asynchronized response, and non-response. So in general, all of the requirement for RPC core, we support it with OR. And all of this RPC protocol was tested and run in our company very well. And beyond the RPC core, TARS provides some service management function as well. So you can see once you it can help you deploy thousands, even millions of server or service in your physical server. It can deploy thousands of millions of software service to your physical server. Maybe just very easily, you can have some web interface, web URL to deploy it very easily. And once lots of tons of software service was deployed in the physical server, we provided another ability to let you monitor the service and figure out which one is ranking good and which one maybe we have something wrong. So you can do the action item to make our whole system run very healthily. And we provide a log aggregation as well, and you can trace how is the application called. So like application A called to application B, and called application C. So you can figure out you can trace this very accurately. And in some use case, maybe the application was deployed in a different area, and we provide some zone optimization functions. We provide load balance, flow control. So lots of our service management functions provided TARS as well. So another key advantage and key features for tars will be in support multiple language. So anyway, you can write, you can in the server side, you can write your code in Go, in PHP, whatever, and you can send a request to the, or sorry, in client side, you can write your code in Go or in PHP, and you can send the request to the server side. The server side can be written in another language, maybe C++, maybe Java, maybe Go, whatever. So it provides multiple language support as well. The last bullet will be it can be incorporated into DevOps and CI/CD, lots of things. Yeah. So that's the architecture for TARS. It's a very important and key component for our platform. So this page was just trying to highlight or letting you guys understand TARS is not a private product in our Tencent. It can also be open sourced in 2018. So right now it's a Linux Foundation project, and you can download the code on the GitHub. You can use it if you want it. And in China, it's well adopted. A lot of companies like so you can say Tencent, Weibo, and lots of Chinese companies here. They have adopted TARS. And the use case are in Tencent, you can see that we provide lots of service for our customers based on TARS framework. So that's it. So and lots of around 9,000 people has joined the project, and they have contributed to their code to TARS framework. So that's the information for TARS. And in the future, we're trying to the blueprint will be released soon, and the first release will be Akraino release R2. And we are trying to release something like, give me a second. We're trying to release here. We are trying to release the ICE TARS and the distribution mode and the vertical and some of the vertical application. So that's all of the information will be released soon in Akraino R2. So more will be coming in the future. Stay tuned. So that's it. So you guys, you have any questions for that?
Okay, there's a question. Hold on.
Okay, so I agree with you.
Hey Robert, a nice presentation. My question is TARS dependent on 5G or can it work on 4G and 3G network?
Yeah. Oh, I got it. For this, and we have invested more stuff for time in 5G. That's true, but it's not only limited to 5G. It's 4G is running as well, and we have to do some tests in our local company with run 4G network. Frankly, it's 5G in the future, but 5G is not mature yet, so we have to do lots of tests on 4G as well. So the clear answer is it will be run well in 4G network. Yeah.
So what you're releasing in R2 will be tested on 4G, is that right? Is that assumption correct?
Yeah. So we are the demo for our release 2 is in it can be in 4G, it can be in some fixed land network. Which means it's just a demo to let you understand how the different components can work together and provide a service for the car service. So this network maybe it's not a key issue for a demo. Yeah, if you want to deploy in a real network, that makes sense as well. But I believe maybe it's not the Akraino. The Akraino lab is just correct me if I'm wrong. I believe Akraino lab is just provide a demo for people to understand it and to test it, but it's not a real product deploy. So it's different from deployed in the real 5G network or 4G network. So this deployment a little difference. Yeah. So that's my understanding.
Okay, there's another question.
So I have two questions. So one is, how do you test? So you can't drive a car all around and subject it to real-time situations, right? The second question is about what kind of sensors you need in the car so that the solution works like a charm.
Okay, I answer first question first, and the way we test it, like what you said, we have our lots of car in China where we install the sensor and something on top of the car, and we rent a car on the street, and we will use the camera to grab the information from the street. That's where the data comes from, and then we send the data to the MEC platform to let the MEC platform to process the data and get a result and send a result back to the driver on the car. So that's what we did. That's the way we test in China. We have a team in Peking, and they do this work a lot in China. For the second question about the sensor, frankly, maybe I need to prove from my boss to whether it's available to distribute here right now. So if you're interested in that, let me know. I double check with my boss and feedback information mail. So yeah, that's it.
Thank you. Any other questions? Okay, looks like we're good.
Okay.
Thank you so much.
Thanks for having me.